Hello everyone, welcome to this lesson. Today we're going to be talking about exponents, which is the very first topic in grade 11. Later on we'll move on to roots and surds, equations and inequalities, and so forth, depending on what you recommend me to do. Now when we talk about exponents, what are we referring to? Now exponents are mathematical symbols that represent repeated multiplication of a number by itself. They are written as superscript number, for example 2 to the power 3, which automatically means 2 multiplied by 2 multiplied by 2. Now exponents have laws in which we operate with. You cannot go on and answer an exponential question without knowing and understanding the laws. Now these laws, there's multiple of them, but only 5 are mostly put into practice. So from law 1 to law 5, which is what I'm going to explain thoroughly. For the first law of exponents, it says when you multiply the same bases, you add the exponents. It gives us this example that we're looking at: a to the power m multiplied by a to the power n, which is equivalent to a to the power m plus n. If it were numbers, if we were to replace the exponents with numbers, for example a to the power 2 multiplied by a to the power 3, then it would have been equivalent to a to the power 2 plus 3, which is also equals to a to the power 5. This is what the first law tells us. The second law says when you divide the same bases, you subtract the exponents. Now these bases have to be the same. If these bases are different in any way, you cannot subtract these exponents, or else whatever you do from there will be wrong. Now the third law of exponent, this tells us when you are raising a power to a power, you multiply the exponents. Now what does raising a power to a power means? This means a base raised to a particular exponent enclosed inside the brackets multiplied by an exponent that is lonely outside the brackets. Now when you get a sum like this, you just simply multiply the exponents. You don't do much, you just multiply them. That is what raising a power to a power means. If you can check at this example, law number 3, a to the power m inside the brackets raised to the power n outside of the brackets is equals to a to the power m times n. Now this can be represented as a to the power mn mathematically. So for the fourth and fifth law of exponent, these laws always depend on the third law. If you understand the third law, then the fourth and fifth law won't give you any problem, because you're basically doing the very same thing that you're doing on the first law. You are raising a power to a power, but now the only thing that you need to understand that is different here is that in most cases the variables or numbers inside the brackets do not have an exponent. Now we should remember that every variable has an invisible exponent of 1 if no exponent is written, or every number also have an exponent of 1. So you multiply that invisible 1 with the exponent that is outside, which is raised to whatever is inside the brackets. That's what the fourth and fifth law of exponent simply tells you. Now you can put these laws into practice when you're answering exponential questions. There's another law that says it is not mentioned above. It's not categorized as part of the exponential laws, but this law tells us when the power is 0, then the answer is 1. Whatever number you might have, either it's a variable or it's a natural number or a whole number per se, 1000 to the power 0, the answer will still be equals to 1. A to the power 0, the answer will be equals to 1. That's what it basically say. When we're working with negative exponents, we always try to avoid the negative exponents. So you need to represent everything as a fraction. Now it will always be represented as 1 over whatever number was raised to the negative exponent, but now you don't show the negative exponent. For example, we have 2 to the power negative 1. That can be represented as 1 over 2 to the power of 1. Okay, so for the first example, we are given this expression and we are asked to simplify this fully. Now In this expression, you can see we have 5a to the power 0 plus open bracket 5a close bracket to the power 0. Now we're going to use the laws of exponent to fully simplify this. Now remember, between the 5 and the 8 is a multiplication, meaning that this exponent of 0, it only affects the a, doesn't affect the 5. So I'm going to write the 5 as it is, as there's nothing else we can do but write it as it is. So first write the 5. Either you open the brackets or you can put a dot to represent the multiplication sign. Now a to the power 0 is equal to 1. As we have explained, anything to the power 0 is equal to 1. We put in the 1 plus. Now because of this bracket, we'll use law number 4 of exponents, whereby this 0 will multiply the invisible one of these two numbers inside the bracket. So it's negative 0 multiplied by 1. We still have 5. Remember, here is a multiplication, so you represent the multiplication. A to the power of 0, so it's gonna be a. Now this exponent will multiply this exponent, now we're to the power of 0, even here to multiply to the power of 0. Now we can simply simplify this. This will still be 5 multiplied by 1 plus 5 to the power of 0 is 1 multiplied by a to the power of 0, it's also 1. Now when you add this into 5 multiplied by 1 is still 5 plus 1 multiplied by 1 is 1. Now the final answer of this is 6. Okay, let us consider the following example. We have x to the power 3 over 2 is equal to 8. Now such question comes and they say solve for x. Now to solve for x, whenever you are provided an exponent but in a form of a fraction, you need to find a way to turn that fraction into a whole number. Now how are we going to turn that fraction into a whole number? We're going to use law number 3, which is raising a power to a power. Now we can express this as x to the power 3 over 2 multiplied by 2 over 3 is equals to 8. Now you'll see the reason why I raised it to the opposite of the fraction that we're given as a fraction. Now this will give us x. 3 multiplied by 2 is 6. 2 multiplied by 3 is also 6. So 6 over 6 is equals to 1. Now if you want, you can write the 1, but if you don't want, there's no reason to write it is equals to 8. But remember, in mathematics, whatever you do on the left hand side, you need to do it on the right hand side. So since we raised this exponent to 2 over 3, we're supposed to raise the 8 to 2 over 3. So 8 is 2 over 3. Now the x is simplified. Now we need to simplify the 8 to the exponent of 2 over 3. It cannot be expressed in this way. Now how do we go about doing this? We need to reduce 8 to its prime factor. Now how do you do that? There's no reason to think. There's a trick on the calculator. You just press whatever number you want to reduce to its prime factor, which is 8 is equals to shift and then fact. It will give you 2 to the power 3. So 8 can be expressed as 2 to the power 3. So now we'll have x is equals to 2 to the power 3 raised to 2 to the power 3. Now either you turn this exponent of 3 into a fraction, or you just multiply what's your numerator with your denominator without writing the power of 1, because it's not necessary in this level of mathematics that we are in. So this 3, if you know how to say, if you want, you can put this in a calculator, but I'll just skip that part. This 3 will cancel this 3. Now you will be left with x is equals to 2 over 2, which gives us x is equals to 4. Now you have successfully simplified equations. Now for the next video, I'm gonna do more complex sum on exponents. Then afterwards, I'll move on to next topics. If you like the video, please like and subscribe, and please share it to someone that you think it might help.